Hello, my name is Stephanie Rust, and I will be introducing you to the procedure of conducting a one-dimensional consolidation test. You'll need a few things to begin. The first is a couple of porous stones and filter paper in large and small sizes. You will need a load cell, which consists of a cap and ball, as well as the load cell complete with ring and bolts, and of course the outer cell itself. You will need to have a ring, and in this case your ring will already have the specimen prepared in it by your instructor. The instructor should have especially ensured that the top and bottom of your sample is very smooth. The instructor should have recorded the empty weight of your ring, the diameter of the ring, and the height of the ring. The first thing to do with your specimen is to weigh it with the ring. It is important to ensure that you place the ring on the scale and not the soil, or the soil may attach to the scale and slip out of the ring. You will then record the weight, and we are next going to assemble the specimen into the load cell. You will remove the collar from the cell and the bolts. Next, you will place the larger of the two porous stones in the bottom of your cell. Next, you will place the larger filter paper on top of the porous stone. Roll it on carefully to avoid air bubbles and smooth. Next, you will take the specimen and place it as close to center as possible in the cell. Now you will place the smaller piece of filter paper directly onto the soil in the ring. Again, roll it carefully to avoid air bubbles and smooth. Next, we will place the last porous stone on top of the filter paper. We're now going to add the collar to the cell, and we may have to wiggle it a little bit to get everything centered and in place. Next, we are going to fasten the screws to tighten our assembly. We are now going to place the cap and ball on top of the porous stone. From here, we will proceed to place our cell into the load frame. We are now going to place the load cell into the load frame. We are now going to lower this bar to meet this ball and match the indentation ready for it. Tighten the top screws. And use a level to ensure that you are indeed level. Once the cell is firmly placed into the frame, we are going to inundate the cell with water. This simply allows us to maintain a constant water content. Ensure that the water is covering the top of the porous stone, and when you come in to change samples or loads, make sure that it is always covering the porous stone. Consider it a houseplant and keep it watered. Your instructor should have provided you with a predetermined loading sequence. You will now need to set your frame for the first load. For this demonstration, our first load will be 7 psi. To begin with, you want to ensure before you begin that this is pointing to low load and this dial is pointing to off. We will now use this knob and slowly direct it to 7 psi. This will be close enough. Since it is pneumatic, it will alter and vary very slightly. You will also need to ensure that your dial gauge is properly touching the pin and that it is zeroed by pushing this green button or a clear button on your particular dial. We will now begin the software to take our readings. Now that your load frame is ready, we are ready to begin the software. First, you will open the Humboldt testing software, which your instructor will tell you the location within your computer. Once the software is open, you will choose New Test. From there, you will choose User Defined with free in parentheses. You will now choose the Open Template option. Double-click on something called the Pneumatic Consolidation Test template. Next, you will select the device by choosing the drop-down menu. Choose Device 1. After this, you will choose the appropriate input. Your particular consolidation load frame should have been labeled 1, 2, or 3. Choose the appropriate one. In this case, we are using input 3. Next, you will double check your start condition, and it should be first points taken at initial values. We will now check the stop condition, and it should be operator stop. From here, we are going to click Run Test or the green button. The computer will prompt you to know where to save your test data. Your instructor will have a folder set aside for your section to save your data. For this demonstration, we will use the desktop. Name your file, your name, and the load that you are using. Make sure you type load because you will have loads and unloads that are the same magnitude. Click Save. Make sure that your dial is zeroed one last time. And when this button turns red, you will flip the switch to load on your frame. You have now returned 24 hours later, and the computer has used its acquisition system to record your data. It is now time to stop the current test. You will push the red Stop Test button. You will also turn this load off on your load frame. From here, you will see that you have yellow and white bars on your test data. You will go up to the top and click the Save icon to ensure you haven't lost the last readings. Next, you will click on the Excel icon and choose Export Test Data. Be sure to type into the spreadsheet the name of this test with the magnitude of the load and whether it is load or unload. From there, you may save the data to the place in the computer that your instructor has designated. You may see a warning about macros. Just choose yes. Now you may X out of the Excel spreadsheet and you may close the test within the Humboldt program. From here, choose New Test and repeat the beginning options of how to set up the next load. Now that you have just completed and closed your final loading sequence, you are ready to disassemble your setup. For this, you simply turn your load dial as low as it will go, usually about 0.2. Now switch the load and you will have released your specimen. You are now able to take the cell out of the load frame, pour out the water, disassemble it, and take the water content of the specimen within the ring. I have poured the water out into the sink, ensuring that I took the cap and ball off first. I'm now going to disassemble by taking off the screws first, pulling off the collar, and pulling out the specimen. Remove the porous stones and the filter paper, and take your wet weight because you will be using a water content of the sample within the ring. This now completes the instruction on how to perform a one-dimensional consolidation test.